Welcome to part 3 of our notes on groundwater. And we're going to begin today by talking about groundwater flow nets. A map of groundwater contour lines with groundwater flow lines is called a flow net. And water table contour lines are similar to topographical lines in a map. They essentially represent elevation in the subsurface of the water table. And we know that water table contour lines are constructed to join areas of equal static water levels. And groundwater flow lines, which represent a path of groundwater downslope, are drawn perpendicular to the contour lines. And we're actually going to do a couple activities where one called Trouble in Paradise, another one, it'll go with the flow. Great activities produced by the state of Wisconsin and the Department of Natural Resources. We're going to take a look at static water levels and how groundwater flows and how it could contaminate things. Now remember, groundwater always moves from an area of higher elevation to an area of lower elevation, and perpendicular to the lines, the flow nets, the lines that we put on the contour maps. Now, water table contours in drainage basins roughly follow the surface topography, but it does depend greatly on the properties of the rock and soil types, whether it's an aquitard, an aquiclude, or an impermeable layer, or if it's something more porous. And so when we look at something like this, we can see it well right here. We can see the flow lines, the water flow lines, the flow net, and we can know that water would flow perpendicular to those lines. So these lines are giving you a pretty good idea of which way the groundwater flows. And understanding this is important. If you were ever to, say, buy a house out in the country, you'd want to figure out which way groundwater flows. And you'd want to know, for example, if you're going to move into a new place, and if, say, you bought 5 acres, but right next to you was a mega farm and they spread manure all the time. If there's a slight pitch in topography and it's coming towards your place, you might be a little bit concerned, because if they don't treat the manure, if they spread the manure too thick, or if too heavy and it gets into the groundwater, that's going to flow downhill towards you. So having a rough understanding of how this works is important for you if you were to ever buy some property. Now, one of the problems with groundwater usage is overdrafts. And overpumping will have two effects. One, it's going to lower the water table, making it necessary to dig a deeper well. And it can also actually change the groundwater flow lines. And this is an interesting diagram. Let's say you bought this little house. You might say, oh, this is a nice house. I've got a barn. No problems. But let's say a neighbor moves in. A neighbor puts in a big mega well. Maybe they put a pool in back. If you can see from the yellow line, they're actually drawing the water down. The water's actually dropping. But let's say they sell their house to a mega company and they're just pumping out hundreds of thousands of gallons of water. Even though at one point in time your well was sufficient, now look at how much water they pumped out. You might have to put in a new well. And what they call this is they call it overdraft, and it's actually creating a cone of depression. And this is not an uncommon thing happening in the state of Wisconsin. Now, pumping water from a well causes a cone of depression to form in the water table at the well site. And so if you had well A, B, C, and D here, and if B was a high capacity irrigation well, you can see how much deeper it is. If it started pulling water out, there's a good chance that eventually wells A, C, and D, harder for D, but definitely plausible for A and C, they may run out of water because it would create a lower cone of depression. Now, almost half of the United States population uses groundwater and as a primary source for drinking water. In many locations, however, groundwater withdrawal exceeds natural recharge rates, and this is known as overdraft. And we've done some work on something similar to this before. What do you call it if the natural resources are being used faster than they can be replenished? If you're thinking of the term, oh, it's a non-renewable natural resources. Well, in some locations in the United States, groundwater is non-renewable. It's not being put back in as fast as it's being pulled out. Now, the Ogallala Aquifer underlies Midwestern states such as Texas, Oklahoma, and New Mexico. And that's a huge aquifer. Now, other states such as California, Arizona, and Nevada actually use the Colorado River to get a lot of their water. And all these locations, but I should say both of these locations, have serious overdraft issues. If you've ever seen the Colorado River, it's a mighty river, but by the time it flows into Mexico, it's not much of a mighty river anymore because most of the water is used for drinking water or for irrigation. So in such areas such as this or the Ogallala Aquifer, the water table is drawn down permanently. Therefore, groundwater is considered to be a non-renewable resource. So here we can see the Ogallala Aquifer. It's a huge aquifer, one of the largest aquifers, if not the largest aquifer in the lower United States, the continuous United States. Now you might say, wow, Wisconsin, we don't have any issues with water. Well, here's a chart that shows that there are some parts of the state. I was talking earlier about Green Bay having issues. There's a problem in the middle of the state, mainly because it's such a sandy soil. Water flows pretty easily through it. And then mainly down here in the southeastern part of the state, mainly because a lot of people live down there. So there are parts of the state, even Wisconsin, where we got a lot of lakes, like 14,000 lakes. Even in Wisconsin, we have some water shortage issues. Now, the Ogallala Aquifer is actually composed of water-bearing sand and gravel that underlies about 400,000 square kilometers. And it's hard to believe that we're using that much water that we're drawing it down, but we definitely are. Now, water is being used for irrigation at a rate up to 20 times more than natural recharge. So we're using up 20 times faster than we can put it back, or Mother Nature can put it back anyway. So water levels in many parts has declined and the resource eventually may be used up. So what can you do? Well, there's simple things you can do to save water right here in Baraboo, right here in your own house. One, run your dishwasher and washing machine only when you have a full load. Water lawns during the early morning hours or evenings when temperatures and wind speeds are lowest, so you don't waste a lot of the water due to evaporation. Simple things like take shorter showers instead of baths. A full bathtub requires about 36 gallons of water. Try to do things like don't leave the water running when you're brushing your teeth. How many of you do that? Do any of you shave? Well, do you leave the water running when you shave? And conserving water is do it because it's going to it's the right thing to do, and that's what it says right here. But look at the other side. If you live in the city of Baraboo, you actually pay for water. If you live in West Baraboo, you pay to use the water. If you live in a country, you might say, well, I don't get a water bill, but you pay for the electricity to pump the water. So it'll actually save you money as well. So what are some things you can do to help protect groundwater? One, recycle. 50% of our waste can be recycled, and this includes composting organic material and taking other products to recycling centers. This will help prevent contamination of the groundwater. Use native plants to landscape your garden/yard. A lot of the native plants are designed to be in Wisconsin's climate, which can be dry from time to time. But a lot of times you see houses have all these beautiful flowers, but as soon as it gets dry, as soon as it gets really hot, those flowers wilt away and they die. Divert your stormwater into your landscape by directing downspouts to gardens, sometimes they'll call them rain gardens, to your lawn or into a barrel. I've got several water barrels that I use to water my plants in my garden. And there's actually been some summers where we've had enough rain. It'll rain maybe once or twice a week, where the rain barrels capture all the water. There's been some summers I haven't had to put any tap water on our plants. We've been able to get everything off our roof into the rain barrels, and we've had more than enough to water our plants. Use good fertilizer practices. Do not fertilize in the winter. The frozen ground offers no path for the movement. And I know most of you aren't going to go out there and water your lawn when it's got 3 feet of snow in it. But there have been problems with farmers trying to spread manure in the wintertime where the ground's not porous enough, and for some reason there might be a freezing rain, or for some reason during the melting of the snow, a lot of that manure runs off into the streams because it doesn't have a chance to get into the ground and to fertilize the soil. And here's an interesting quote from Benjamin Franklin. Well, when the well's dry, we know the worth of water. We don't think much about water right now. But if your well was to go dry, if your city was to run out of water, we would start paying a lot for it. And then I think we would know how much it's really worth. So when the well's dry, we truly will know the worth of water.